All right, so let's just get the ball rolling. So just be mindful, no multiple choice will be covered today. It is just the structured aspect of the question. So for section 2, we know that we are required to show all working. So we are to use first principle to differentiate this. Now, what we can do when we look at questions like these is that we can go ahead and find out what the derivative of this would be without using first principle, which means that if I was to differentiate this, I'm expecting to get the derivative of 2x, x squared is 2x, the derivative of 5x is 5, and the derivative of the constant is 0. So if I should differentiate this quadratic right here, I'm expecting to get 2x plus 5, which means that in the back of my mind, when I'm working out this question using the method of first principle, I know I should end up with this as my answer. All right. So f of x we're already given. So we need to find f of x plus h. So be mindful that f of x is equal to x squared plus 5x minus 3. So if we have f of x plus h, it means that anywhere we see x, we're going to put x plus h. So we're going to have x plus h all squared, because we see an x there. We're going to have 5 times x plus h, because we see an x there, and we just have the minus 3. So x plus h all squared, meaning that x plus h is multiplying by itself. In the interest of time, we're just going to write it out, 2xh plus h squared. 5 times x is going to give us 5x, 5 times h is 5h, and then we have the minus 3. All right, so this is what is f of x plus h. Now, in using the formula to work it out, or the method of first principle, we're going to have the derivative of the function is going to be equal to f of x plus h, which is all of this. So that's going to be x squared plus 2xh plus h squared plus 5x plus 5h minus 3 minus f of x. What is f of x? Minus f of x, which is x squared plus 5x minus 3. And then it's going to be all divided by h. Right? So this is now where we expand and simplify. So this is going to be equal to x squared plus 2xh plus h squared plus 5x plus 5h minus 3. The negative distributed over this bracket or multiplied by this bracket is going to give us minus x squared minus 5x plus 3. And then we're going to have all divided by h. Oh, sorry. Notice what I forgot in this. I didn't write the limit. I just started solving. So my apologies. You know, sometimes when you're excited to solve a problem, the limit as h tends to 0. All right. So right here, we can identify a few things, and we can simplify. X squared will cancel with this minus x squared. 5x will cancel with this minus 5x. And 3 will cancel with this minus 3. So all of those we can cancel, because you have a positive x squared and a minus x squared. You have a positive 5x and a minus 5x. You have a negative 3 and a plus 3. So all of those are opposite of each other, so they will cancel out. So we have the limit as h tends to 0 of 2xh plus h squared plus 5h, all divided by h. Please note here, h is common in the numerator. H is common between all the different terms in the numerator, so we can factor out h. All right. So we have the limit as h tends to 0 of h. Then you have 2x plus h plus 5, all divided by h. Now, what is it that we see happening in the expression that we can simplify? H is multiplying this expression here, and h is also dividing. So because one is multiplying and one is dividing, they are performing opposite operation of each other, so they will cancel with each other. All right. And then by using direct substitution, the limit as h tends to 0 of 2x plus h plus 5, when h is 0. All right, so when h is equal to 0, all that we're going to have left is 2x plus 5, which is what our f prime x is. So we needed to do all of this to end up with this answer that we did in one line, right? But it's just a matter of the method. The method is different, so you have to know how to use this method to solve these questions. All right, bear that in mind, please. If there is anything I need to clarify, you may go ahead at this time and ask your question.
Sir?
Go ahead.
So there's gonna be a formula sheet on the exam?
Yes, there is going to be a formula sheet.
Question again, sir. Best, what if you do a derivative, sir, and it's a particular question? It alright if you just use one of the formulas in on the sheet, as a guide?
Are you going to be required to use a formula that is on the sheet?
Yeah.
Well, it
Like
depends. All right,
oh,
it
it depends on
depends.
the question?
Yes, it's going to definitely be depending on the question, because the reality of it is the questions on the question paper can be such that you don't necessarily need all the formulas that are on the formula sheet. So
Oh.
yeah, so it's not that you're going to get a question on every. All right, take for instance this question right here. It is such that the question is given, and it says that you have to use the method of first principle, and they give you the well, basically the formula or the operation formula that you're going to use to calculate or to do your computation. So you don't have to jump to a formula sheet to find this, because this is already given to you. See what I mean?
Yes, sir.
Yeah. So once you're using the first method from first principle, it must be in this form. So that means you don't have to go to a formula sheet to find that. So yes, there's going to be a formula sheet, and you know, what you are able to use a formula sheet to do is going to be relative to the question. Because not all the formulas, because say for instance, we have 20 formulas on the question on the formula sheet. You are not going to be given 20 questions that is going to relate it to all of the formulas. Following the reasoning?
Yeah.
All right. All right, anybody else, you can go ahead at this time. If not, we're going to be moving on to other questions.
Wait, sir.
Go ahead.
How much set of questions can we expect?
How much what?
Set of questions.
All right, so by the time I'm finished working through this, you'll have an idea because all the questions that we're going to be doing now are in the same amount that is going to be on the exam paper, minus the multiple choice questions.
Okay, sir. It's on the 29th, right?
I would have to check back the exam schedule, but I think that's correct.
Yeah, because I saw one on the 23rd also. So I was making sure.
Give me a second and I'll check and try to update you before the end of our session. So it's a continuation of the question. All right. One of the things that you have to bear in mind, your first derivative is also known as your gradient function. All right, so it is your gradient function, which means that if you're asked to find the gradient at a particular point on the graph, you would have to use your first derivative, which is your gradient function. So if we want to find, so f prime x is equal to 2x plus 5. So at the point 2, 2, 5, it's when x is equal to 2. Because notice here, that's your value of x. This is your value of y. So f prime 2 is equal to 2 times 2 plus 5. So that is going to be equal to 4 plus 5. So that's equal to 11. So at the point 2, 5, the gradient is 11, which means that you have a positive gradient. So that means the line is sloping up, right? So remember, negative gradient, line slope going down, positive gradient, line slope going up. All right. So from your first question, it can be expected to carry out that amount of working.
Sir,
Go ahead.
the answer should be 9.
Oh, yes, Mercy. Well done. Whoa. Whoa. I know. I would have seen, over the years, you're marking off paper to see some of the computations that students end up with. And let me tell you, it is easy to make because with confidence, you notice me move on. You recognize me start write a next question. That means that if I'm in a exam, I am already moving on to answering a next question, which means that I'm confident in myself already, so the answer is 11, move on. So it's not that you don't know, it's not a matter of not knowing. It's just that for some strange reason, you end up with an answer that you can't even explain it. And sometimes you give back students the paper and it's like they're wondering like what was happening, that I got this. And it's just really an innocent mistake. It just because it's not a case that you don't know. Because that's basic computation. That doesn't require any deep thinking, any deep formula, any deductive reasoning or anything like that. It just happens. So with this in mind, all I'm saying is that pay attention in the exam because we don't want people to be, losing a mark here or there or stuff like that. So you saw my mistake a while ago. So take that as an indicator to say, I need to pay attention when I'm doing my test to make sure that I focus on the computations. All right?
Sir, could you
Go ahead.
repeat what you said about the slope of the gradient when it's positive?
Oh, the line slopes going up. So
Oh, okay.
negative. So when the line slopes in this direction, it has a negative gradient. And if it slopes going up in this direction, then it has a positive gradient.
Okay.
Because this graph gives us a minimum graph. So it slopes down and then up. This part over here could very well be another linear function or a quadratic. Let me explain. Let me just write something else there so you can understand what I mean. This could have been something like x squared plus 2x. This could have been like 3x squared plus 5. So it could have been anything over here. The concept that we're looking at here is that you have two things multiplying, so we have to use the product rule. All right, so that is what we're looking at. We're not looking at what is in the bracket. It is the principle of how to work it out. That is what we're going to be focusing on. So it could have been anything in the two brackets. So it could have been a quadratic function in the first bracket and so on. So for using the product rule, so we look at three rules. We look at the product rule, the quotient rule, and the chain rule. So the product rule says, if I'm taking the derivative with respect to x of u times v, it's going to be equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. All right. So what this gives us is that if we say that this is u and this is v, then u is equal to 2x minus 2. So the derivative of u with respect to x is going to be 2, and v is equal to sine x plus 6. So the derivative of v with respect to x is going to be equal, differentiate sine, we're just going to get cos x. Cross multiply. Why do we say we cross multiply? Because it is u times the derivative of v with respect to x, which is the first part here, plus v times the derivative of u with respect to x. All right. So what do we end up with? We end up with cos x times 2x minus 2 plus 2 times sine x plus 6. So f prime x, I think I'm going to need a little more space than that. F prime x, which is the first derivative, is going to be equal to cos x times 2x is going to give us 2x cos x times negative 2 cos x 2 times sine x is going to give us 2 sine x, and 2 times 6 is going to give us 12. So that would be your final answer for the derivative of that function. Look at it and see if there is anything I need to clarify before we continue. Now, bear in mind, if we have it as y is equal to e to the ax, then the derivative is going to be equal to a times e to the ax. All right. So here is going to be the derivative of the power. All right. So if we should go ahead and differentiate what we have here, the derivative of this power, if we differentiate 6x, what do we end up with?
6.
Wonderful. So negative 2 times e to the 6x times the derivative of the power, which is multiplying by it, which is 6. And if we differentiate sine x, we just get cos x. So your final answer is 6 times negative 2 is going to be negative 12 e to the 6x plus cos x. Let me know if there's any part of it I need to clarify.
Sir, how did you get a 6?
This 6 right here.
Yes, sir.
Oh, so it's the notice right here where we're multiplying by a. We said that we have to differentiate the power. So if the power is 6x, so if you have the derivative with respect to x of 6x, so if we differentiate 6x, we're just going to get 6. Not sure about it?
Okay.
No, when I say okay, is that you understand, or so we don't want to just move on, you know, want to say you're sure about it. Are you sure about it?
Well, me just see where you see how you
No, that
get
is
the
not
6.
it. All right,
I don't know
no.
which other way we say
No,
regarding.
no. Understand what I'm saying. You're going to do an exam, so you must be sure that you know, say, yes, it's equal to 6x. And if you're not sure, then you can say, sir, how you get the 6? Because that's what we're about, you know. And I'm not asking you because me want to say, or me I pick on you or anything like that. I'm asking you because I want to ensure that you are sure going into the exam. You must know. All right, let us pay attention to it so we can get an appreciation. Now, the rule for differentiation says if I get a function y is equal to x to the n, if I'm going to take the derivative of this function, dy dx, or f prime x if it is written in terms of x, is going to be equal to n x to the n minus 1. So how did we get here? The rule of differentiation says you multiply by the power first, and then you subtract 1 from the power. So this is the rule that we're using for differentiation. So you multiply by the power first and then subtract 1 from the power. Now let's look at it in terms of 6x. y is equal to 6x. What is the power of this x right here? Anybody can answer. What's the power of this x?
1.
1. So if I'm going to take the derivative, it's going to be 1 times the power, and then after I do that, I'm going to subtract 1. So 1 times 6 is going to give us 6, and then I'm going to get x to the 1 minus 1, which is going to give me 0. Right? Now, we learned from indices that anything raised to the power of 0 is equal to
1.
equal to 1. So x to the 0 is 1. So what we're saying here is that it's going to be 6 times 1, which we end up with 6, which is what we get right here. So that is all we do the differentiation, all right? So bear this in mind. So that is the rule that we use anytime we're differentiating. So you multiply the coefficient of the variable by the power, then you subtract 1 from the power, all right? So that is what we did to end up with this. And now the derivative of the trig function is just simply by virtue of the law or the rule. You have to know that the derivative of sine x is cos x, and you have to know that the derivative of cos x is negative sine x. You have to know that. All right? You just have to know that. All right. Hopefully you're comfortable with it now. And if you're not sure, you still can ask again. I'm not limiting you to say, okay, because I do this, you must understand, so we have to move on. If you're not sure same way, you just need to let me know, and then we look at other examples. So the reason why we're doing this lesson today is to ensure that we have an idea of what is coming. And then if there's something that we're doing that you're not sure about, you must get sure right now, because there's no other time to be sure. So you must get in the know right now, because there's no other opportunity to get in the know. So if you don't know, you need to understand, you need to know, ask yourself, why do I not know? And then if I am not in the know, then I need to know. And there's no other way of putting it. So bear that in mind as we work through the questions, because you have to have an understanding of what we're doing. All right, please. So write an expression. So here we have one linear expression divided by another linear expression. Now we call them linear because the highest power of the variable is 1. So they are linear expression, right? So if we were to represent these on a graph, we would get a straight line. So here we have a linear expression. This part is going to be u, and this part is going to be v. Why are we using the quotient rule? Anybody remember what operation we're doing when we get a quotient? When do you get a quotient? You're dividing. Very good. So when you have u divided by v, your result is going to give you a quotient. So for the quotient rule, it's v times the derivative of u with respect to x minus u times the derivative of v with respect to x, all divided by v squared. Now bear this in mind. Bear this in mind. For the product rule, the order in which you write them, if you write v times the derivative of u with respect to x, and then plus u times the derivative of v with respect to x, you will still get the same answer, because the order in which we add will not change your result. But the order in which you divide will change the result. Because if we say 6 divided by 3, we get 2. But if we have 3 divided by 6, we get a half. So it matters. So notice how the formula is written. It is written as v first times the derivative of u with respect to x minus u times the derivative of v with respect to x. So this matters. It's not any order. This matters. All right. So u is going to be equal to 6x plus 4. So we take the derivative of u with respect to x. So if we differentiate 6x, you see it over here, so I mean, luckily for us, it's just another type question. It's going to give us 6. Anybody remembers what happens when we differentiate a constant or a number by itself?
Just leave it, sir. No, just don't add it, sir.
All right, so we just don't have it. So another way of writing that, somebody said it, is equal to
0.
0. Wonderful. So we're backing up each other. And then now we have v times v is equal to 2 minus 3x. So the derivative of v with respect to x, what would we end up with here? Somebody help me out.
So 3, sir.
Go again.
Minus
Negative
3.
3.
All right. So notice the minus is in front of the 3x, so we have to take the sign with it. So mindful of that, please. Now, here we go. So it is going to be dy dx is going to be equal to v times the derivative of u. So we get minus u times the derivative of v. And then we can just distribute when we are simplifying. So what do we end up with? 6 times 2x is going to give us 12. Sorry, 6 times 2. I said 2x. 6 times 2 is 12. Minus 6 times 3 is 18x. Now notice here, you have a negative times a negative, so it's going to give us a positive. So everything that comes over here is going to be a positive. Negative here and a negative here, so it's multiplying. Notice the brackets together mean that they're multiplying, so the negative times the negative going to give you a positive. So it is going to be, even if you want, let's do this. Let's not worry about that right there, so that I mentioned. Let's do it this way. Write back this minus, and then we multiply over here. So negative 3 times 6x is going to give us negative 18x. Negative 3 times 4 is going to give us negative 12. All divided by 2 minus 3x all squared. So we're going to get 12 minus 18x. Now this minus will multiply or distribute over everything that is in the bracket. So we're going to get plus 18x, and then we're going to get plus 12. All divided by 2 minus 3x all squared. So look at what is happening here. This will cancel with this. So we get that dy dx is going to be equal to, the numerator is going to be 24, and the denominator is going to be 2 minus 3x all squared. Now look at it, and if there is any part of it you're not sure about, you need to let me know.
Even sir, just join. What's the topic?
It's not a topic by itself, it's a review of what we should expect for the exam. So we're looking at type of questions that we can expect to see for the exam.
Okay, sir.
Yeah. So what we will be going through today will focus on differentiation and integration, which we know is the module 2 component that we're going to be doing on the assessment.
Okay, noted, sir.
So we did a few questions earlier. So what you might want to do is take note of where you have joined the class, and then you can just look at the recording to catch up on the first part of it. All right.
Yes, sir.
Yeah, man. All right. Please note that even for this function here, you can be asked to find the gradient. Let's expound on that a little. So this is your first derivative. Let me just backtrack a bit. So as you know what I'm talking about. Notice what this one, you find the first derivative. So the first derivative, remember, is your gradient function. And notice it says, hence find the gradient at the point. So after you find your first derivative, you can be asked to find the gradient. So this function right here will give us a graph because we can graph this thing. This is something that you can actually graph on your graph paper. It's just that it's going to give you a function that have what we call an asymptote. No, you don't need to worry about that because it's not part of what we're doing. But I'm just saying it can be graphed on your graph paper. It's just that your
Sir,
denominator, go ahead.
sir, like, say if I bring graph paper to
Oh,
exam,
no,
sir.
no, 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 no. Not for you. We didn't do
Okay.
any graphing. I'm just saying it can be
Oh,
graphed on the graph paper. So it's just that your denominator cannot be zero. So we can be asked to say what is the gradient at a particular point on this curve of this, this graph. So yeah, we again we can be saying find the gradient at the point that's something that you can be asked to do. So we know that the x is 4, and we know that the y is -1. So dy dx when x is equal to 4, this is going to give us 24 all divided by 2 minus 3 times 4 raised to the power of 2. So it is going to be 24 all divided by 2 minus 12 all squared. So it is going to be, I'm going to just carry it out to the side. 24 all divided by -10 all squared. So we're going to get 24, oh sorry, 24. -10 squared is going to give me what? Somebody help me out. -10 squared.
100.
100. So this is your gradient, but you can also write it as a decimal. So you can write it as 0.24. So you can keep it as a fraction. There's nothing to say unless the question specifies, but there's nothing to say you can't leave it here. So you can very well leave it here, or you can write it as a decimal, or you can reduce the fraction. You can go ahead and reduce this and say and write it as a fraction in its simplest form. So you could be asked to do this as well, because once you're finding the gradient, you just substitute the value of x into the first derivative or into what we know it also as the gradient function. So let's remind ourselves of the rule of integration. So if we're integrating x to the n with respect to x, it's going to give us x to the n plus 1 divided by n plus 1 plus the constant of integration, which is c. The reason why we add the constant of integration is because this is what we call an indefinite integral. So you have indefinite and you have definite. So this one is an indefinite integral. So we had the arbitrary constant, which is c. Okay, bear that in mind, please. So if we're integrating here, add 1 to the power, divide by the new power, we're going to get 5x cubed divided by 3 plus add 1 to the power, divide by the new power. So notice this is 3x over 2. Let's add 1 to the power. We're going to get 2. And we now need to divide by the new power, which is 2. So let's go pay attention to what is happening here. You have 3x divided by 2, or 1.5x. This is the same thing as 1.5x. So the power here is 1. So you have to add 1 to the power, which is going to give us 2. And you also need to divide by the new power, which is 2. That does not interfere with the 2 that is already there. So not because there's a 2 there, you say, oh, 2 there already, we don't need to divide by 2 again. No, that's not how it works. You have to divide by 2 because that's the process of integrating. Notwithstanding that it's a fraction, you still have to do it. You know what I'm saying? So the rule must maintain, you know, must be true, must maintain. And then we're going to say the integral of a constant is the constant times the variable, and then the arbitrary constant c. So what we end up with, 5x cubed over 3 plus 3x squared, 2 times 2 is going to give us 4, plus 4x plus c. All right. You are free to go ahead and ask any questions at this time. All right, let's continue. Now, when you'd have looked at the rules of indices, you'd have been minded that if you have a to the negative n, it's equal to 1 over a to the n. Why is it that we're talking about this? Because this fraction here is written in this form. So I want somebody to help me out with this. If I have 7 over x squared, notice it is written like this form right here. How would I write it so that it is in the form where we have a base and a power? What would I write?
7x to the minus 2.
Wonderful. Thank you very much. 7x to the minus 2. Thank you for that. So this we can rewrite as the integral of 2 sine x plus 7x to the negative 2 dx. What do we get when we integrate sine x?
Negative cos x.
Wonderful. So we're going to get negative cos x and it's multiplied by 2. So we get negative 2 cos x plus add 1 to the power, divide by the new power. So if we add 1 to negative 2, what we end up with?
-1.
-1 divided by -1 plus the constant of integration. So our final answer is going to be -2 cos x. You have a positive divided by a negative. So we get -7x to the -1 plus c. Look at it carefully for yourself. Let me know if there is anything I need to clarify. All right, so if we're integrating these type of functions, you can use this way, or you can use U substitution. So either way, you're free to use. It would be totally up to you. So integrate, add 1 to the power, divide by the new power, which is 5. And if we should differentiate this bracket, we're going to end up with, what would we get? Derivative of 3x plus 4, what you get?
3, sir.
3. So if we have y is equal to 3x plus 4 and we take the derivative of it, we're just going to end up with 3. So multiplying by 3. All right. So the final answer is going to be 3x plus 4 to the 5th power, all divided by 15 plus c. Look at it, make sure you have an understanding. If not, you're free to ask your questions. Now, if you're asked to evaluate a function, it means that you must find the finite or the definite answer for that function. So in this case, you're asked to find the integral of this function, which simply means you need to find the finite value of the integral of this function. Now, notice we have a specific range or the limits through which we are integrating. The upper limit is 5, the lower limit is 3. Integrating 4x, we're going to get 4x squared divided by 2. Integral of 5 is just going to give us 5x. And it is from 3 to 5. This can simplify, we get 2x squared plus 5x from 3 to 5. All right, I'm going to use up the space over here, so I'm just going to bring it up to this side so we can maximize on the space. So we're going to substitute when x is 5 and when x is 3. So it's going to be 2 times 5 squared plus 5 times 5. And then minus 2 times 3 squared plus 5 times 3. So this is going to give us 2 times 25 plus 25 minus 2 times 9 plus 15. So 50 plus 25. I mean, this is just, you know, working through every single part of it. But it's not a case where you have to do it, you have to show this amount of working. It's not a must. All right, so just bear that in mind. Uh, 75 minus, what is this? 33. So this is going to give us what, 42? So that is what you would get for the finite answer for this function. Go right ahead if you have any questions. All right, since there is no question, I'm going to go to the exam is 2.5 hours. The exam is 2.5 hours. Now, what I would recommend is that you, well, first things first, ensure that you skip through your paper until you see end of exam. So you must know how many questions is on the paper. It's in the instruction. Once you read the instruction, it will tell you. But never stop working until you see end of exam, which means that we don't want nobody to come out and discuss in the paper and then say, what did you get for this question? And I say, which question? Answer that the question and never dip on the paper. No, because you never skip through until you see end of exam. You must know that your exam paper has ended, which means there's no more question after that. Also, if you get your paper and you look at it, sometimes when you're skipping through a paper, you can read, you can even just glance over a question, and once you look at it, you know that, okay, this would be the answer for this question. If you know it at that point when you're just glancing over, make a note of it. So even on the exam paper, you can write it. Now, notice now, I didn't say you're answering the question on the exam paper, because all answers must be in the answer booklet. Don't answer any of the multiple choice on the exam paper. Don't answer any of the questions on the exam paper. What I'm saying is that while you're skipping through the paper, if you read a question, look over a question, and you can answer it right away because it's so fresh in your mind. I would recommend that you make a little jotting of it at that moment, because while the exam is going, if you start to become stressed or anxiety starts to kicking, there are some things that you know, even when you know it, it just run away from the mind. Go ahead, Miss Hamilton.
The exam is only multiple choice, sir?
Oh no, miss. No, there is two sections to the multiple choice. There is a working out part, which is the part that we are looking at, and then you have the multiple choice part. So as I mentioned to the class earlier, we will not be doing any of the multiple choice questions because oftentimes we do repeat multiple choice questions. So we don't normally share the multiple choice questions. All right.
Yes, sir.
Mhm. So we're looking at the structured part, which is the part that you have to work out to get the bulk of the marks, because each of these questions can have a 2 to a 5 mark weighting, which means that the question will either value 2 marks, 3 marks, 4 marks, 5 marks, that kind of a thing. So because they are weighted so heavily, it would be necessarily important that you have an understanding of how to work through these type of questions. See what I'm saying? All
Yes,
right.
sir.
Mm-hmm. All right, go ahead, Robinson.
Yes, sir. Good afternoon.
Yeah, man.
When is the final question?
I didn't hear your question. I just
Sorry,
hear
I was
from.
asking. Yeah, sorry. When is the final question? Sorry, the final exam.
Oh, as I mentioned, I'm going to check for it. To see. Let me go into my email now and see what's the timetable.
And is this online?
Oh no, sir. It's face to
Have to find a
face.
site.
It's face to face.
I didn't
Either
get
in,
wait for me.
it's face to face either in Mandeville or in Kingston.
Okay.
Yeah.
So for the multiple choice, you get the quiz you gave us the other day,
Mhm.
right? We just circle the answer on that sheet though.
Oh no, yeah, man, that's fine. That is relating to that paper. This is the final exam now, where you will be provided with an answer booklet. Because bear in mind, I did mention to the class last time that everybody, even though you did the work on Moodle and some did not get an opportunity to do it on Moodle because of everything that was happening, I had asked that everyone upload their assignment to the Teams. All right, so bear that in mind. Please note as well that the assignment 2 is also in the Teams, which you should be forming your groups and working on to be submitted. Based on the due date that was given. So I did not take the initiative to form any groups because I want persons to take the initiative to do that. All right. We must develop these kind of skills to form groups and assign leaders and work to get a task completed. So that should be working on at the same time. So that you do in the Teams or in the Moodle, that's fine. But for the exam purpose, you will have a exam sheet, answer booklet, which you will have to write all your answers in that. So no answers should be written on the physical paper itself. All
And
right,
this is for the last module, module 3 only.
no, there is only 2 modules, so it is for module 2.
Module 2 only will be the
Yeah.
final exam.
Yes, sir.
Okay.
Yes, sir.
Go ahead.
Yes, sir. On the issue of the groups, would it be permitted, sir, if we had 4 members to one group?
If I remember correctly, I think that's what the instruction did indicate. Anybody can back me up on that?
It indicated 3, sir, but
It
based on the
indicated 3?
numbers,
Okay.
yes. So we're just
Alright,
asking if it
yeah.
would be permitted to add an extra one.
Yeah, because the class is not an even number. So arguably, you can find that a group may have 4 persons, but it's not a group of 5 and 6 and no, not that at all. So where a group of 2 can be facilitated, sorry, a group of 4 can be facilitated. It's now 5 and 6 and those type of things. All right.
Okay, sir. Thank you for that.
Yeah, man. So the calculus is on the 29th of April. That's a Wednesday. So bear this in mind. The final exam is on the 29th of April. Starts at 9 a.m. And it's both in Kingston and in Mandeville. So bear that in mind. So it is the 29th of April based on what I'm looking at now on the exam. And it says the final exam timetable for semester 2. So semester 2, 2025-2026, Wednesday, April 29, 2026 at 9 a.m. There is a calculus final and receipt, and that is for both campus. All right. Now, you have to bear in mind that when we're looking at trig, pi is equal to 180 degrees. So even things like this, we can even make a note of once we're in the exam, so that we don't forget them. When you integrate sine, you get negative cos. So this is going to give us negative 2 cos x, and we're integrating from pi over 4 to pi over 2. Now, sorry, on your calculator, you may have the button pi, but you're not using that button on your calculator. You are going to do the conversion. So, sorry, this is going to be equal to negative 2 cos of pi over 2 minus negative 2 cos of pi over 4. What is pi over 2 in degrees? If pi is 180, what is pi over 2? In degrees.
90 degrees.
90 degrees, right? So on your calculator, you're going to say cos of 90 degrees. You're not going to say cos of pi over 2. You're going to put in the 90 degrees, all right? Cos of 90 degrees, you should know it out of your head, but if not, you can use a calculator. What is cos of 90 degrees?
0.
So the cos of 90 degrees is going to give us a 0. So what we're going to have here is going to be negative 2 times 0 minus, what is the cos of 45 degrees? Well, I should have asked you. So pi over 4 is 45 degrees. All right. So what is cos of 45 degrees?
.707.
So 0.707. So this is 0 minus so this is going to give us negative 1.414. So when you multiply by 2, and the negative of the negative is going to give us a positive, so we'll end up with 1.414. Now, you will bear in mind that I would have been saying for the longest while, you have to practice doing computations with a calculator. Now, if you go into the exam and don't know to do these things on your calculator, you would be mindful that I have been saying it to persons, because we can't expect that we're practicing to do computation with our phones and then we just automatically go into the exam and we just know how to manipulate the calculator like that. Is because you have not been doing it or using it for a long time, it may become difficult to identify where all the functions is and all of that. So I would hope that we have the necessary skills to manipulate the calculator, because these things can be a challenge if you have not been practicing with the calculator and just primarily be using your phone. All right. So be conscious of that when you get your calculator for the exam. Just do a quick scan to see where your functions are, cosine, tan, that kind of a thing, to make sure that you know how to work through the questions using those strict functions, whichever one it may be. All right, so we only have 2 more questions left to cover for the exam. So we have a graph that, or a function that is 3x squared plus 2, and it is bounded by the lines x equal to 1, x equal to 5, and the x-axis. So what is it that they're saying? Let me just give a quick little sketch of what this is saying. So here you have the graph y is equal to 3x squared plus 2. And between this region right here and this region right here and the x-axis, you have this portion of the graph that you are finding the area for. Say for instance, right here is where 2 is. So between 1 to 5, this is the line. So you have the line 1, x equal to 1, the line x equal to 5. You have the curve, and you also have the x-axis. So all of these lines bound this particular region. Right? So this portion of the curve line, this straight line, the x-axis, this straight line bound this region that you're finding the area for. So the area is going to be equal to the integral from 1 to 5 of the function 3x squared plus 2, and you're integrating with respect to x. Remember, if it was volume, you would have to multiply by pi, all right? So we're mindful of that. So this is going to be equal to integrates. Now, please note, drawing the graph is not a must. This is not part of your question or part of the answering of the question. This is just me showing you a demonstration based on what we would have even looked at, where we use the different graphs and the different worded problems to find the area or the volume. Yes? So all you need to know is how to set it up based on the fact that you are doing the integral of the function. So it is from the lower limit to the upper limit, because the smaller number is 1, the bigger number is 5. So you have the lower limit, upper limit, the function, and you're integrating with respect to x. So this is going to be 3x cubed divided by 3 plus 2x, and we're integrating from 1 to 5. We can simplify here. So we're going to end up with just x cubed plus 2x, and we're integrating from 1 to 5. So we're going to substitute when x is 1 and when x is 5. So we have 5 cubed plus 2 times 5. And then we have 1 cube plus 2 times 1. 5 cube is 125 plus 25 minus 1 plus 2. This is going to be 150 minus 3, which is going to give us 147 units cubed. Sorry, units squared. We're finding area, so it is a measure in squared units. Look at it carefully and see if there is any part of it that I need to clarify before we continue to the next question. So what is it that I'm saying as it relates to this question? We have to concretize this in our minds right now. Yes? In the sense that I must either understand it, that this is how I would do it. And if I don't understand it, then I need to be asking the question as to which part of it I'm not sure about so I can get the clarity. Right? So some of the questions that we have worked today, you need to have a concretized conceptual knowledge of, yes, I am sure that this is how the process is to work out these questions. I know that this is what I'm going to be required to do once I'm sitting the exam. And once you know that, then you know, work towards that. All right.
Sir,
Go ahead.
do you always subtract the bottom number set from the top
Yes.
number?
Yes. Finding the area or definite integral. So if you take in the integral of a definite function, if you're taking the definite integral of a function, let's say from a to b of f of x with respect to x, it's going to be equal to, once you integrate the function, you're going to get the integral function, which is what you would have gotten for your answer. From a to b, or what we call the primitive function. From memory serving right, I think this is called the primitive function. So it is going to be f of b minus f of a. So whatever the upper limit is, you substitute that into the function. Whatever the lower limit is, you substitute that into the function and you take the difference of those two.
Sorry, I have a miscalculation.
Which part of it now?
The 5
2
cube
times
plus
5.
right.
Yeah, it should be 10. See that? My word. Thank you. So that's going to give us 135. So this is going to give us 132. All right, thank you for that. I mean, again, I don't say we don't know. Just happen. So sometimes we see some students do some errors in their calculation. We can't bash them for it. We just say, boy, you know, it's just sad. And the reason why we're saying that it's sad is because we recognize that the person could have gotten a higher grade. Now, how do we mark for things like that? Because I think that is important to discuss, because somebody here may be saying, then boy, if me get that wrong, do I get the entire question wrong? No. You often find that when we're marking for mathematical concept, we take into account where an error is made and how do you continue after the error, right? So if your error is made and with that error calculation, you continue using that error calculation correctly. What do I mean by correctly? Do you recognize when we had it as 150? We continue with the calculation to say 150 minus 3 to give us 147. That is a correct calculation, even though it is incorrect. I wonder if you understand what I'm trying to say. Anybody unsure of what I'm trying to say? So let's go again. I'm saying that is a correct calculation, even though that answer is incorrect. Do you understand what I mean by that? It's a yes or no, guys. Because I need to be able to know that what I'm explaining, you are getting. So why am I saying even though the answer is incorrect? Because the correct answer is 132. But it is correct that 150 minus 3 gives you 147. So because you would have used the incorrect answer of 150 and you carry out the rest of the calculation correctly with that incorrect number of 150, you would still be given the mark for everything that comes after, even though it is an incorrect answer. So what do we do when we're marking questions like that? We know that commonly we'll use a stick to indicate that the question is correct. So you would not be given a stick to say that the question is correct. You'll be just given the marks for the question, but not a stick. So when you get the question correctly now, you get the mark and you get the stick. But because the question is incorrect, you will only get the marks for the portion of the question that minus the 1 mark or so for the error part. And then you get the mark for the rest of the question and no tick, because the tick would indicate that, yes, it's a correct question plus the marks. So say for instance, this question is worth 5 marks, so you'd get a stick and then your 5 marks. But what we had previously, which was the 150 minus 3 equal to the 147, equal to the 147. So instead now you may get a 4 marks here and no stick at all, because this is not correct. Even though you get 4 marks, it is just not correct. We just indicate that because you'd have made the error right here, we can just put the correction to say it should be 135, right? And then we continue with it. Even sometimes students will be working a question, right? And they work the question and get the answer, but they continue working. That I would have seen that many times, which means that the student would not have recognized that they needed to stop right here. So what we do in a case like that, say for instance, the question stop right here, but then just for argument's sake, you just continue with another few lines down to get to something else. And say for instance, what you end up with down here is incorrect. So right here, so is incorrect. But you would have had the correct answer. So let's go again. What the question requires as an answer, what you should have done to get the correct answer for the question stops right here. But you blow to right here, pass right here. So you get this part up to this part correct, which is what the question requires. And you continue working till you end up somewhere down here, which for some reason you continue working and you get an incorrect answer. The question will only be marked right up to here. Sometimes you will see on your paper ISW, which means that it says that you're ignoring the subsequent working. The reason why we're ignoring the subsequent working is because the mathematics solution is going to be designed to mark up onto the steps that are correct to the answer for the question. So even though you continue beyond the steps that are required to solve the question, we don't consider that part any at all, because I have to mark the question up until the part of where the answer is. And once I reach up to where the answer is, because I see it, I just stop right there. Because, okay, you continue working, we just say ignore subsequent working because it's not part of the answer. It is not required for what the question is asking. All right, hopefully you're following the reasoning. All right, so, and the next question, which would be what would culminate your assessment. So what we're given is the gradient function or the first derivative. And from your first derivative, you need to find which equation was differentiated to give you this gradient function. All right, so that is what we're looking at. Now, mind you, once you are comfortable with what we have done, then it means that you should be well on your way to representing yourself well in the assessment. All right. Now, to find the equation, it's going to be the integral of the derivative function with respect to x, 4x squared minus 5x plus 3. So when we integrate this side, we're just going to end up with y, which is the antiderivative. And when we integrate this part, notice, okay, let's look at something here. This or these points right here are not your limits for the integral. So you're not going from zero, sorry, from zero, well, you're not going from 0 to -3 or from -3 to 0. No, nothing like that. These are just the points. This is just the coordinate of a point that is on this curve. All right. So they don't represent the limits. So when we integrate this side, we're going to get 4x cubed over 3 minus 5x squared over 2 plus 3x plus c. All right. So when x is equal to 0 and y is equal to -3. Now bear in mind, these two can be any numbers. So the x value can be any number, the y value can be any number. You just need to substitute them in to the equation. When x is equal to 0 and y is equal to -3, so the y is -3 equal to 4 times 0 cubed over 3 minus 5 times 0 squared over 2 plus 3 times 0 plus c. So -3 is going to be equal to all of this is 0, all of that is 0, all of that is 0 plus c. Bear in mind, they could have been numbers, you know. It's just based on the question. They just give us 0, but these could have been numbers, and you just have to carry out the calculation. So -3 is going to be equal to c. So that means the equation is going to be y is equal to 4x cubed over 3 minus 5x squared over 2 plus 3x minus 3, because what we did was to find the value of c, which is the constant of integration. Hold just a brief moment, please. Hold just a brief moment.